All right, 10-3. We only have one sheet. That should be a positive. All right. So, apparently I've lost. No, I found it. So a hyperbola is just a set of points equal distance from the foci. Notice that we have two foci also, just like we had with an ellipse. Foci is plural for focus. I'm crooked. I'm always crooked. It does come in two branches, so it's kind of like two opposite parabolas. Come on, Omar, you're behind the... They have a transverse axis that intersects at the center. So I'll talk about what that is. There is actually two of them. And I'm going to give you, well, I'll give you some of the extra formulas if you want them. But again, I rely heavily on graphing. So here's an example of what your hyperbola looks like. You notice we have two equations, two different ones. How are they different from the ellipse? There's minuses. What changes from here to here, though? The x's and the y's change rather than the a squared and the b squareds, right? Okay, so let's see how this changes. How is this going to be different? Oh, and by the way, a is not always bigger than b like it was on the ellipse. That doesn't matter. So you've got a is going to equal your vertex on your real axis. In fact, I wouldn't even necessarily worry about the I wouldn't necessarily worry about those 2 points right now. We need to find C. C is much more important than necessarily A and B. I don't like the way that this is noted here. Here's this other thing that you have to memorize, although it's not really that hard to memorize because don't you kind of already know it? How is that different than the one from the ellipse? You add, and it looks exactly like what? Pythagoras theorem. Now here's how you might be able to remember that. C squared we add here, but we have a subtraction here. On the ellipse, we have addition in the equation, but with C squared we do what? Subtract. So they are opposite to each other. So that's one way that you can remember the difference, since you're not getting the formulas on your test, right? Emphasis on not. And I'm not just saying that, and I'm going to give you the formulas. They're really not going to be there.
Well, you did that once.
I did do that once, but not always. All right, so let's assume for chuckle's sake that our center is right here. Call that HK, just like it has been. That hasn't changed. And I'm going to put on this one a horizontal transverse axis. So what that means is that my foci are going to be along the x-axis direction. So you're going to have a point, let's say about here and about here. That point is going to be, kind of look like the vertex of your so-called parabolas, the branches that are going to go off in this direction. But then you're also going to have a distance. I think I'll make this one maybe way up here and way here. So the transverse axis is not necessarily the bigger axis on these. What the transverse axis tells you is where your foci are. It's important to know where your foci are so that you know exactly where to draw the hyperbola branches. So what you're going to do is once you have your center, one of these is going to be A, one of these is going to be, or 2A and 2B, right? So same thing as the ellipse. But if I have a horizontal transverse axis, how would I know that? How would I know that I have a horizontal transverse axis? How do we know it with the ellipse? How do these change? Notice where A squared is? A squared is underneath the X, and A squared is underneath the Y. That hasn't changed from the ellipse. So if your A squared is underneath the X, your transverse axis should go in the direction of the X. It may be the shorter one. It might be the longer one, it doesn't matter. But what you're going to do once you get your A, 2A here, and your 2B here, you're going to draw a box. or a rectangle. And the purpose of this rectangle is to help get the shape of your hyperbola branches. Remember, I didn't really care about the shape of the parabola. I didn't care if it was wide or skinny when we were doing it. That wasn't our focus. But here we need to get the shape of these. So then once you do that, get your box in there from your A and your B. Then you're going to put in what are called asymptotes. Asymptotes, if you recall from Algebra 3-4, didn't you have asymptotes when you had fractions with polynomials? And you had to find what the denominator could not equal, your excluded values. Didn't that create asymptotes? And didn't your graphs approach that asymptote but never crossed it? The same thing happens here. So we're going to have dotted asymptotes because technically they're not part of your graph. So this is an asymptote. And then you're going to have another one, so they create an X. And they go through the corners of this rectangle. Now, there are lovely equations to the asymptotes, and you can see them right here. So here's your asymptotes equations. Now, these ones you are going to have to memorize. And let's look at how the difference between them. So if your horizontal transverse axis would be for like this equation here where a squared is under the x squared, then this one would be a vertical transverse axis, right? And this right here is your transverse axis going in this direction on this one. So your asymptote for this one, what's the difference between these equations? Any difference at all amongst them? The A and the B. So this is your change in difference. So notice that when you have a horizontal transverse axis, the A is underneath the X, right? I don't know if that makes any difference. Isn't your B under the X over here? Right? So whichever one is underneath your X, that's what's going underneath here. So if in your original problem, A squared is underneath your X, A is underneath B here. In your second equation, your B squared is underneath your X, your B is underneath here. If I were you, that's how I'd memorize it. But you are going to have to know these and these. This one's easy. You should already have that memorized now, right? So you've got essentially a week to get those under your belt. You can do that. All right, then you're going to end up creating your foci. Your foci, we'll talk about when we go through this, how we're going to find our foci. But your foci are going to end up being, if this is my transverse axis, your vertex, if you want to call it that, of these branches of the hyperbolas are going to go here. Your foci, just like with the parabolas, are going to go on the inside here and the inside here. So your hyperbola is going to look like this. You want to make sure the hyperbola just comes real close to that asymptote, hits that vertex, and comes real close here. These asymptotes are what are creating the shape of that hyperbola. Is it going to be super skinny? So am I going to have two things that look like this? So these ones are like this, but I can actually close it and make it skinnier, right? Or open it and make it fatter, couldn't I? And the same thing could have happened. I could end up with my hyperbola branches up here, and those could open and close and make them skinny and fat. So for this one, I'd end up with something fairly fat. And for this one, you want to really try to hug those asymptotes. And there we go. Now here's your formulas for your focus, if you want to memorize them, but you won't see me. So you've got H minus A, comma K. And then this would be H plus A, comma K. And of course, if they were up here, wouldn't it be affecting your K instead? The only other thing that I think that you need to know is that this, if this is your transverse axis here, which would be 2a. Then this right here, bless you, this is called your conjugate axis. And wouldn't that be 2b? Or not to be? Yeah.
For that focus, did you mean h plus a?
Did I put a k? Yeah, that's an h. Thank you. Didn't I say h?
Yeah.
I think I did, but I wrote a k. Oops. All right, so you ready to graph some of these? No, we're not going to do the other one. The other one, you'll get to some of them as we go through here. I just don't want to take the time. This one, I mean, it might not look much different than this, other than the fact that my hyperbola is going to come up this way. So if you want to just sketch it in with a vertical transverse axis, your hyperbolas are going to go in this direction. You're still going to have diagonal asymptotes. You're still going to have the box, but your focus are going to be up here, right? And down here. All right, so you ready? Here we go. Let's look at example 1. So what comes first, x or y? X. So if x comes first, my transverse axis is along the x-axis, so it's going to be horizontal. And if you want to, for your own purposes, so that you remember what you're doing, that means that our hyperbola is going to go in that direction, right and left, instead of up and down. So the first thing that I need to find are A and B, so I can set my box and my center of my hyperbola. So I'm going to start, bless you, I'm going to start with number 1, my center. Can I tell my center by looking at that? What's my center? -1, 4. So let's go ahead and plot that. I need to put hash marks. You're probably going to want to go out, we have to go out to about, square root of this is 12, so you want to probably go out to 15, right and left. And then go up to about 10 on this one. All right, so now we can plot our center of -1, +4. I hate graphing on non-graph paper, just saying. And then find A and B. So what's A? Remember, these don't change, right? This is A squared and B squared. What's A? Square root of 144 is 12, and what's B? 5. So because A is underneath X, I'm going to take 12, I'm going to go 12 to the right and 12 to the left. And those are going to be the left and right bound of my rectangle. All right, so that's my distance of A, and then my distance of B, I'm going to go up 5. And then down 5. And so now I can create this kind of dotted rectangle. The more accurate you are on your rectangle, the better your asymptotes are. So it's really important that you get that as accurate as possible. Questions so far? Are we good? All I did was go A to the right, A to the left, B up, and B down. Then you might want to put here, for step 3, for your note purposes, use the above to plot the box. So that's what we just did. Typically at this point I'll put in my asymptotes, but I'm going to help you find the foci. So find foci. And then aren't we going to use our c squared equals a squared plus b squared? So that equals 144 plus 25, which is equal to what? And then isn't that a nice perfect square? So what does c equal? 13. So how far out from the center is the outside of this box? From center to here is how far? 12. And so don't we just have to go 13 total? It's just like the ellipse. We want to go 13 to the left and 13 to the right. So won't our foci be right here? So this up here is really C, isn't it? C. C. Told you I didn't memorize formulas. So there's our foci. And then if I had to name the ordered pair of the foci, name that ordered pair, what is it? It's not negative 13. It's negative 14. So negative 14, 4, because we started at negative 1, right? And we added a negative 13. And then the other one, we started at negative 1 and added a positive 13, so what's that? 12, 4. It's hard when it's not on graph paper to read that. So then our other foci over here would be 1 to the right. And then before I can draw my ellipses, I have to put in my asymptotes. So step 5 would be to draw in asymptotes. And I'm going to do that in purple. So just go from corner to corner and draw a dotted line. And you want to extend these asymptotes out as far as possible because it gives you a better shape. I messed up just a smidge there. And the asymptotes should be intersecting at the center, which they do. If they don't, then you did something wrong when you made your box. The other thing that you have to be worried about is that you make sure when you draw your branches that you don't hit the focus, that you hit this vertex, so to speak. So then go ahead and draw them in. These are real fun for me to do, especially when they're super skinny. Okay, and then draw this one in. I just need to see an attempt made to approach those asymptotes. And then the fun part is we get to write the equation of the asymptotes. Yippee! I won't, yeah. No, just don't cross it. I'll know what you're doing. All right, so because we're going along the x-axis, A is underneath our x this time because x is first, right? So our A is in the bottom of our fraction in our equation. So we've got y equals, what's k? 4. So 4 is something that we have to change every time, plus or minus. And then what's b? 5. And then what's a? 12. Times x minus, or I guess what's h? Since h is negative, is it x minus? Isn't it plus 1? Because h is negative. So as far as I'm concerned, you can write your answers that way, or you could split them apart into their two different equations of y equals 4 plus 5/12 times x plus 1, or y equals 4 minus 5/12 times x plus 1. Either one. So the only thing that's really different is that your foci are outside the box, whereas in the ellipse it was inside the ellipse, right? And you're still using C to find that foci. You're drawing in this box and the asymptotes. That's really the only thing that's remarkably different. So flip it to the back. This stuff should be easier because we've had it before. We have to actually put it in standard form, correct? So you go ahead and put it in standard form. Bearing in mind you're going to have a negative. So I'll be doing it up here while you're doing it at your seats. Oh, and let me just give you a hint. How do you know whether x comes before y? Yeah, isn't your x squared negative here? So you want it to come second. Whichever one is negative, that's the one that comes second. So are you okay there? Did you get that far? You note that you had to factor out a negative from the x squared and the 2x in order to get that minus out in front. So if you don't have a greatest common factor for that second set, you do have to factor out a negative. That left us with a 4 times 16 on the right and a 1 times negative 1 on the right, giving me negative 47, 64, and negative 1, which all adds to give you 16. So now how do you get 1 on the right here? So everything gets divided by 16. So I end up with y plus 2 squared. I am going to write it over 1, and if you do that, that's fine. You don't technically usually do that, but for your purposes, I want you to see it. So now what do I do? Let's find our center. What's that? Negative 1, right? Or 1, yeah. 1, negative 2. So let's go ahead and plot that, and then we've got square root of this is 1, square root of that is 4, so at most we need to go out 5, 6, right? Are we going to have a horizontal or a vertical transverse axis? What comes first? The y. So it's going to go along the y-axis. So that means that we're going to have a vertical transverse axis, which if you want to make sure that you, and because you're going to make a mistake, it's easy to make a mistake of putting the hyperbolas in the wrong place on your asymptotes. So I always like to draw a picture to double check myself. So what do I have to find next? A and B, so what's A? Which one of these is A? The first one, so square root of 1 is 1. And B? 4. So that means I'm going to go up 1, right? And down 1. And to the right 4 and to the left 4. Remember, your transverse axis isn't necessarily the longer axis like it was on the ellipse. So we're just going to go up 1, plot a point, down 1, plot a point, to the right 4, and to the left. Alright, so then make your box. So step 3 was to make that box. What's step 4? Foci, right? How do you find foci? C squared equals A squared plus B squared. So this is lovely, 1 plus 16. So what does that mean C is going to end up being? Square root of 17. The square root of 17, remember I said you could do like something 0.5? So about how far is square root of 17? It's really like 4.1, right? But you could do 4.5, especially on this. It doesn't really matter if you're that super accurate. So our foci are going to go 4.1. Is it up, down, right, or left? What's your vertical transverse axis? Oh, it's vertical. Oops. Transverse axis is vertical, right? So that means that we're going to go up 4.5. So from here up a little smidge, and then down and a smidge. So how would I write the ordered pairs of those? So what's this one? What's its x value? How far to the right did I go? 1. And then remember we went from here, so if it's a square root, what's the y value of the center? -2. And then didn't I add the square root of 17? Right? And then the other one, wouldn't it be 1 comma -2 minus the square root of 17? So if you had to write the equations of the foci, remember you're starting from the center. All right, asymptotes. Put them in. As long as possible. You see how easy it would be to put your hyperbole branches here? Right? You okay, Miss Abby? Yeah, okay. So this is a really fat one, isn't it? So we're going to approach from here. Oh, goodness. That wasn't very good. No, I'm going to go this way. Action arrow. Save myself sort of in the end. So that's what our hyperbola looks like. Let's write the equations of the asymptotes. Last one. So is A or B underneath the x? Here's our x. B squared is underneath that, right? So don't we have y equals, what's our k? -2. Plus or minus our a, because it's a over b. Our a is 1. Our b is 4 times x minus 1, right? Done. All I did was follow that formula. Oh well, I'm not going to make you. One would be the positive, wouldn't this be the positively sloped one and that's a negatively sloped one? I don't care. Okay, so you're going to find the standard equation of a hyperbola given the vertices. The vertices are always on what? This is on the transverse axis, right? So that tells you, that's going to tell you what your center is. It's going to tell you what your A or B is. Which one? A, right? A is underneath your transverse axis, A squared. And then the foci are going to tell you what is. You'll be able to find C, won't you? Because isn't the foci C units away from the what? Center. So let's go ahead and plot those. So my vertices are 1. Alright, so I've got to right 2 and up 3. And then to the right 2, but down 3. So that means that I have a vertical transverse axis. So what comes first then? What's going to come first, x or y? Y. So that's going to be my x. So I knew immediately, because these are vertical to each other, that my y has to come first. Let's find our center. How far apart are these? 6. So because these are 6, what's half of that? 3. So doesn't that mean that this is 3 squared? So now we found a squared. And then the center would be right here, wouldn't it? What ordered pair is that? Bless you. 2, 0. So doesn't that mean that I'm going to put in here a minus and a minus? I'm going to put in my center, my x value is 2, so 2 goes here, and my y value is 0, 0 goes there, because they flip around, right? Because the x has to go to the x, the y has to go to the y. And then this is going to be equal to 1, right? What am I missing? C, right? Or, sorry, C, B. But we've got foci, right? So let's plot those to the right 2 and up 5, and to the right 2 and down 5. How far are the foci from the center? 5. So isn't my C equal to 5? So let's find B. So C squared is equal to A squared minus or plus B squared. So C squared is 25, right? What's A squared? 9. plus b squared. B squared is equal to, what's 25 minus 9? 16. Do I really have to find b? No reason to, right? So we're going to take that and put it underneath here, and then we're almost done. Simplify whatever you can. So don't we just have y squared over 9 minus x minus 2 squared over 16 equals 1. Whoops. And then the last thing that we have to talk about. Stay with me for 2 minutes. This is going to be easy. I don't have any examples to show you, but you will have some problems in your homework. So look at this last box here. You're going to have to classify a conic. What's a conic? A parabola, an ellipse, a hyperbola. Okay, so you're going to have to, and then also notice that there's a circle in here too. That's a conic also. We've just done circles before, haven't we? We're not going to do them again. They're easy. Now let's talk about this. Let's say that I gave it to you in the form of example 2 above. Okay, so just look at example 2 above. That's what they're saying here. It's in this form right here. All I care about is A and C. A and C are the coefficients of what terms? The what? The x squared and the y squared, right? The squared terms. I don't care about really any other one. What if I'm missing the x squared term? Then that means that A is 0, right? And if I'm missing an x squared term, then look at what happens here. If I have a circle, first of all, these are going to be exactly equal to each other. If that's 4, that's 4. If that's 1, that's 1. If that's 3, that's 3. Okay, they will be exactly the same. If you've never noticed it before, you're going to see it when you do this. So circle, those are equal. Parabola, A times C is 0, because on a parabola, you only have one squared term, right? So if you're missing the x squared term, you have a y squared term, but no x squared. Isn't that a parabola? Only one of them is squared. Same thing occurs if you have an x squared but no y squared, right? Same thing's going to occur. In ellipse, A times C is greater than 0. What kind of number is greater than 0? Positive. What kind of sign is in between the two fractions in ellipse? A plus. What kind of a sign is in between the two fractions in a hyperbola? A negative, because look at this one up here. So here's our two squared terms. 16 times negative 1 gives you a negative 16. Didn't we get a negative down here, and isn't this a hyperbola? So they're not asking you to graph it, they're just asking you to classify it. So use that as your knowledge, and that's what the 44 through 51 all is. So don't panic and think you have a zillion of these to graph.